Today I'm here to show you and tell you a little bit about radioactivity. Now, like most people, I've heard of radioactivity and I didn't really know what it was. But I went ahead and did a little research, and now I can give you a basic overview on what radioactivity really is. So, what we need to understand is radioactivity occurs when an atomic nucleus breaks down into smaller particles. There are three types of nuclear radiation: alpha, beta, and gamma. Alpha particles are positively charged, and beta particles are negatively charged. Gamma particles have no charge. The radiations also have increasing levels of energy. First alpha, then beta, then finally gamma, which is the most energetic of all three. Alpha and beta are particles, but gamma is a wave. Another bit to note about radioactivity is that it's pretty much not good for living things. There are times that radiation passes right through organisms with no effect, but there are also times that it hits and affects DNA or replicating cells. Bad things generally tend to happen when DNA is exposed to radiation, and one result of moderate levels of radioactivity can be cancer. Cells produce in ways that are not normal, and high doses of radioactivity can actually kill those cells and eventually you within 24 hours. Modern medicine, however, has learned to use radioactivity to stop cancers. And since they know the excess level of radioactivity can kill cells, doctors try and target the cancer cells with this radioactivity to keep them from dividing. Alright, so now we have to figure out, well, how does radioactivity work? Well, when a nucleus of the radioactive material changes, the remaining nucleus isn't the same as it used to be. It changes kind of like its identity changes. So when that identity actually goes through the change, that's when the particles begin emitting from the nuclei. So as a result of nuclear instability, particles start shooting off of these nucleus, and that is what creates the radioactivity. That is why it's considered a strong force in nature, and that creates tons and tons of different isotopes that are unstable, and that's what we get radiation from. And just so we can get kind of a baseline feel of how radioactivity works, I'm going to walk you through step by step how to cook a mac and cheese in the microwave. And while this is going to be fun for me because I get to eat it later, it should be fun for you because you're learning about radioactivity. So as we put this in the microwave, we should understand that a microwave rotates around in 360 degrees and tries to cook your food evenly. And through the holes in the side of the thing, inside of the microwave radiation occurs. So what happens is that this microwave sends out a different wavelength at a different hertz, and that causes the particles in the nucleus of the air inside the microwave to start shooting off in all sorts of different directions. And that's what heats up the food inside. So there you have it. That's kind of the basics of radiation and how you use it and how it's probably not really good for people. So thanks for watching, and hopefully you have a better understanding than you did before. Bye!